Operation Midnight Hammer by the B-2 Spirit is a masterclass in the art of war. The U.S. sent two groups of B-2 Spirit in opposite directions. One is a decoy that flew toward U.S. outposts in the Indian Ocean, while the main strike package appeared to head east toward Iran. All of this to strike the heavily fortified Fordow Nuclear Enrichment Bunker. This facility is buried deep beneath a thick layer of rock, with its main chamber located approximately 200 meters from the tunnel entrance. The surrounding terrain begins with a gentle slope but becomes steep about 160 meters from the ridge, offering strong natural protection from aerial attacks. Just before the B-2s reached their target, a U.S. nuclear submarine launched a dozen cruise missiles aimed at various nuclear sites in Isfahan. Here's the catch. Reports say hundreds of trucks moved uranium centrifuges away from the nuclear enrichment plant just days before the bunker buster bomb strikes. We'll also look at the B-2 Spirit secret stealth technology, more details all in the video ahead. The U.S. B-2 Spirit bombers strike on Iran's nuclear facilities, codenamed Operation Midnight Hammer. In the early hours of June 21, 2025, a large formation of B-2 bombers lifted off from Whiteman Air Force Base in Missouri under tight secrecy. What followed was a complex play of deception and the art of war. Immediately after takeoff, the strike package split into two separate groups. One group, serving as a decoy, flew westward over the Pacific, heading toward well-known U.S. outposts like Andersen Air Force Base in Guam or possibly Diego Garcia in the Indian Ocean. Meanwhile, the main attack group, consisting of 7 B-2 bombers armed with massive ordnance penetrator MOP bunker-busting bombs, flew eastward toward Iran. This move was designed to confuse the global flight trackers, news outlets, and even Iranian intelligence, drawing attention away from the real strike. Their mission: to strike Iran's most fortified nuclear sites at Fordow, Natanz, and Isfahan. The main force embarked on a grueling 18-hour mission, part of a nearly 37-hour round-trip journey spanning thousands of miles. To keep them airborne, the operation relied on a series of precisely timed mid-air refueling by KC-135 stratotankers. These refueling missions, conducted in international airspace, were critical to the success of the operation. Just a small comparison, this aircraft fuel reserve can fill up 2,000 SUV truck. All this considering it can carry 20,000 gallons or 75,000 liters of fuel. Moving further back, there is another section of the fuel tank. These fuel tanks were specifically designed to penetrate deep into Russian territory, about 6,900 miles, which is around 11,000 kilometers. Furthermore, it can travel double that distance deep into enemy lines while avoiding radar detection, thanks to this rotary air refueling system that extends all the way out, as shown here. This maximizes its range to 12,000 miles with the Boeing KC-135 stratotanker and allows it to remain airborne for 44 hours. That is almost 2 days in the air, which is a remarkable engineering feat. The bombers cross into the Middle East via routes over Lebanon, Syria, and Iraq, though it remains unclear whether these nations have been notified. As the B-2s approached Iranian airspace, the mission entered its most critical phase. U.S. forces unleashed a range of electronic warfare tactics and decoys. Fast-moving aircraft and jamming systems were deployed ahead of the bombers, designed to confuse and blind Iranian radar and missile defenses. At the same time, U.S. fighter jets and surveillance aircraft conducted sweeps to detect any potential threats, whether from the air or from surface-to-air missile batteries. Thanks to their stealth capabilities and carefully coordinated flight profiles, the B-2s went unnoticed. This is the Fordow nuclear facility, one of the most heavily fortified and deeply buried sites in Iran's nuclear program. But what exactly makes it so difficult to destroy? Fordow is protected by a complex network of defenses, including 6 tunnel entrances leading into its underground uranium enrichment facility. The most critical parts of the site, specifically the enrichment infrastructure, are buried deep inside a tunnel approximately 200 meters long, carved directly into the side of a mountain. The main enrichment chamber is believed to sit directly beneath the mountain ridgeline, hidden under a massive layer of rock. From the tunnel entrance to the chamber, the distance spans roughly 200 meters. The terrain itself adds another layer of defense. It starts off with a gentle slope near the tunnel entrances, but becomes significantly steeper about 160 meters from the ridge, providing natural protection from overhead strikes. And here's where it becomes even more challenging. If the enrichment chamber sits at the same elevation as the tunnel entrances, it's shielded by approximately 40 meters of solid rock when approached from narrow vertical angles, around 25 degrees. A bomb dropped directly from above or even at a 40-degree off-axis angle, as would be typical for a high-altitude strike from a subsonic B-2 bomber, would need to break through up to 40 meters of dense mountain rock to reach its target. To overcome this, the U.S. deployed 6 B-2 Spirit bombers, each armed with GBU-57 massive ordnance penetrators, deep penetrating bunker buster bombs designed for hardened targets like Fordow. These strikes targeted the mountain ridge directly above the tunnel network and underground enrichment halls, aiming to penetrate the fortified layers and disrupt Iran's nuclear operations. The B-2s also targeted at least 6 of the known tunnel entrances leading into the facility. Post-strike satellite imagery, along with assessments from weapons experts, confirmed that at least 3 of the 4 main entrances sustained significant damage. Large craters were visible near these access points, indicating a direct hit and probable disruption to the facility's internal infrastructure. Roughly an hour before the B-2s crossed into Iranian airspace, a U.S. Navy submarine launched over 30 cruise missiles targeting the Isfahan nuclear site. A simultaneous attack from sea and air created chaos and stretched Iranian defenses thin, adding another layer of confusion to an already overwhelming assault. At around 6:40 p.m. Eastern Time, 2:10 a.m. in Iran, the lead B-2 bomber released 2 massive ordnance penetrators over the Fordow nuclear facility. Over the next 25 minutes, 14 MOP bombs were dropped across Fordow and Natanz, tearing into the reinforced underground complexes. Almost simultaneously, the cruise missiles struck Isfahan with devastating precision. With their mission complete, the B-2s turned back and exited Iranian airspace just as silently as they had arrived. Let's look at how the B-2 Spirit avoid radar. Unlike normal planes that use rudders and elevators to steer, the B-2 has no vertical stabilizers. This is because any vertical structure would reflect radar waves, which is why they had to design it without vertical stabilizer or rudder at the rear. Instead, they use this technique of split drag rudders to provide directional stability and control in a flying wing aircraft. But there is a catch. As opposed to conventional rudders, the control efficiency of split drag rudders is typically low for small deflection angles. That is why the B-2 Spirit turns very slowly compared to other military planes. Each split rudder consists of 2 separate panels that swing out vertically in opposite directions. When the left split rudder opens, it produces drag and causes the B-2 Spirit to yaw to the left in the direction of the open split rudder. The same effect occurs with the opposing right side split rudder. This is what happens inside the cockpit. When the pilot pushes the left rudder pedal, the left split rudder opens, causing the aircraft to yaw to the left. Similarly, when the pilot pushes the right rudder pedal, the right split rudder opens, causing the aircraft to yaw to the right. The B-2 Spirit Composite can be divided into several parts. Here, we find that all the edges are made of fiberglass epoxy to reflect radar, while the largest part of the wing is primarily made of graphite epoxy. Interestingly, the crew station assembly is made up of aluminum. At the base, since these areas have to withstand a lot of heat from the engine, they are made of titanium, a super strong, expensive material. Finally, we have fiberglass polyamide, a stealthy material able to withstand heat. This is what it looks like with all the labeling and segments assigned to it to give you a better picture. Let's take a look at the $1 billion radar paint technology, which is still classified, but here's what we know from aviation experts. It involves the use of radar-absorbing material, also called RAM. RAM is a polymer-based material applied to the surface of stealth military aircraft, like the F-22 Raptor and F-35 Lightning II. Moving to the belly of the beast and opening the bomb bay door is this weapon adapter suspension, which makes this bomber formidable. While the B-2 Spirit might look small, it can fit around 80 numbers of Mark 82 bombs weighing 500 pounds. Yes, all these 80 weapons can fit inside this weapon adapter, totaling around 40,000 pounds, which is approximately 18,000 kilograms of free-fall gravity weapon system. Depending on the mission, the B-2 Spirit can switch to this rotary weapon system, enabling it to carry around 16 numbers of AGM-158 missiles, which can cost around $1.5 million each. When ready, a B-2 Spirit can drop this weapon payload discreetly. The AGM missiles unfold their wings to fly towards the target, traveling up to 230 miles, which is around 370 kilometers. Let's take a look at how this works. Step 1. The bomb deployment platform. As previously mentioned, a B-2 stealth bomber flies at a very high altitude. When the aircraft reaches the designated location and the conditions are optimal, it can release this specialized MOAB weapon system. The bomb is designed for precision, and the deployment height plays a crucial role in its trajectory and effectiveness. Then step 2 comes the targeting precision. The bomb is outfitted with advanced guidance technology, including GPS and inertial navigation systems, which are military-grade satellites. Then comes step 3, that is adjusting the trajectory. The guidance information and data is then transmitted to the bomb's 4-lattice motors fins located at the rear. These fins can move and adjust in real time, allowing the bomb to correct its course as it descends under the force of gravity. These adjustments are essential because the weapon does not have thrusters to change its trajectory. Instead, it relies on the movement of these fins and a high-altitude drop to control its flight path. This is why the bomb must be deployed from a very high altitude so it has enough time and distance to adjust its trajectory accurately. Here comes the most difficult part, that is step 4. Impact and penetration. The bomb, known as the Massive Ordnance Penetrator, weighs approximately 30,000 pounds, which is around 14,000 kilograms. When it reaches its target, it strikes with immense force, designed to penetrate deep into hardened structures, such as bunkers. The energy upon impact allows the bomb to bury itself over 200 feet into reinforced concrete, ensuring it delivers its payload precisely where it is intended for maximum effect. We make original videos from scratch, so please do subscribe and hit the notification bell for more videos.